Okay, hi there, I'm Hao. This is just another video of me solving random liquid problem. So today we have combination sum 2, which is an extension problem of combination sum, which is problem 39. Please look at that problem first before moving on to this one. So this is the code that we have for combination sum. So the difference now is that each number in a candidate may only be used once, right? So in the combination sum, we can choose a candidate as many times as we want. But now we can only choose one, right? So in our backtracking function here, we need to increment the index one. So this number is either chosen, right, or not chosen, right? We can show this number and then try the backtracking, and then you can pop it off, which means the number is no longer chosen, right? So if we have 1, 2, and 3, we're gonna iterate through this, right? We're gonna pick one, right? And we're gonna call the backtracking function, right? And then we're gonna pop it off. Now it's an empty array, right? And we pick the next number, right? 2. Same thing here, 3, right? And remember that we're using the star index here to avoid duplicate. Okay, so we're only moving toward the right. We're not gonna choose the same number yet. So let's try that to see what we have. So as you can see here, we almost have the correct answer, right? 2, 5 here is matching with 1, 2, 5, right? But 1, 1, 6 here, we have 1, 6, 1, right? So even though combination, the order doesn't matter for combination, right? 1, 1, 1, 6 is the same as 6, 1, 1, but it looks like that the solution asks us to ask our result to be sorted here. So we can sort the input before running the backtracking so that everything will be sorted. Okay, so let's try it again. Oh, yes, the sort. Okay, now it looks really good, right? We have the correct answer for everything here, except we have been duplicates, right? 1, 2, 5, and then 1, 7. Okay, so remember, previously we're gonna have our array is like something like this, right? 2, 3, 6, and 7, and then we are using the star index, right? The star to make sure that we're not going backward, right? So for example, if we pick 2, right? 2, we can try 2 with 3, right? Or 2 with 6, right? And 2 with 7, right? So if we are at 3, we're gonna pick 3, then there's no need to try 3 and 2 again, right? Right. So we only moving forward. Now we are not moving forward, right? Because why? Because we can only pick the candidate once, right? Each candidate can only be used once, right? However, in the combination sum problem, we are guaranteed that each candidate is distinct, is unique, right? But not here, right? We can have like 2, number 1, as you can see here. It is not unique at all. Okay. And remember that the array is already sorted, right? So we're gonna have something like this: 1, 1, 2, 5, 6, 7, and 10, right? Right. We can use the same strategy as we said earlier, right? So if we pick one, right, we can try 1 with 5, right? Sorry, 1 with 2. Yeah, 1 with 1, 1 with 2, 1 with 5, 1 with 6, 1 with 7, 1 with 10, right? So if we pick 1 again, right? Accept the first one, accept this one, right? we're gonna have the same combination again, right? 1, 2, 1, 5, 1, 6, 1, 7, 1, 10, right? And so on and so forth, 1, 7, 10, all kind of combination you can think of. So if whenever we see the same element, right? If the current element is the same as the previous element, we can just skip it, right? There's no need to process this one. Okay. So that is one thing to do, right? To remember to do to get rid of this duplicate, right here, right? So normally our backtracking function would look something like this, right? We're gonna push, right, something in the array, right? We're gonna backtrack this. We're gonna pop, and we're gonna backtrack again, right? Right. So even though there's a for loop here, we only have two paths, right? We either select the element or we won't, right? So we have two paths, so that is two to the end. Because in a worst case scenario, we will select every single candidate, right, to make up the sum. So that is our worst case here, all of two to the end. Right. So this element is either selected or not, right? So yeah, we can just ignore the element, right? So if star index is greater than, so if I is greater than the star index, right? And candidates at I is equal to the candidates at I minus one, and we can just continue. We're gonna skip this element. Okay. Now it worked. Let's submit to see if we pass the test and it worked. Yeah. So thank you for watching.